All right, last category is resolution. It's really specifically motion resolution. There's a couple of tests on this Silicon Optics HQV that are pretty telling. I'll play both of them. One is video resolution loss test, and that's what's it doing with 1080i video material. And so we have it in the Oppo BD93 player in direct mode, which will switch back and forth and change the output of the player automatically depending upon what's on the disc. So video resolution, it'll be 1080i, and then we'll move over and we'll look at film resolution, which will be 1080p. Player will do that automatically. Look at the test pattern, take a look at it. We've already seen this, and it's pretty telling. It usually is. It's fun, you know. It's funny for me at this stage of the game to have de-interlacing problems in products like this. I think I'm very surprised by it. So video resolution loss test is it's a 1080i de-interlacing test, correct?
Right. This is video resolution loss test. There's a film one as well, right?
Yeah.
So this is 60i content on the disc, and the test is basically making sure that the TV doesn't mistake this as 2-3 pull-down material. And if it did that, then you would see all these interlacing artifacts around the spinning bar, and it would look much less smooth. So all of these, all of these are getting it right, and they're de-interlacing video content in video mode, which is what we want.
Which one?
Right there. You see it?
Yeah.
They're also
That's actually another issue which we're going to talk about in a minute. That's
Blip over here too.
What's it name?
There's just a little blip across the line. When
right. That's because this is de-interlacing, and this is 1 pixel high line. And when there's motion, it's going to try and interpolate from above and below, which is why you see the same pixel line flicker on and off.
Is there one that
That's inevitable. It's a lossy. It's inherently lossy.
So in fact, every one of these passes this test.
Right.
Yeah.
No, they all do it. They're all doing
Right.
it. Yeah.
Exactly.
Yeah.
They'll all do the little flicker because
Right.
that's inevitable.
Let's move on to film. So David, you can take it away, because this is what you do for a living.
Sure. So basically, this is testing the TV's ability to extract 24p content out of a 60i signal. Obviously, with video camera, with high motion video content like a TV news or video interview or something, you're going to have it's going to be high motion video content. If there is telecine film, so that's film transferred to video inside a 60i broadcast signal, the TV is going to have to identify similarities between the fields. It's going to have to analyze the incoming image basically and switch into the appropriate processing mode. It's going to have to go into film de-interlacing mode. And as you can see,
The LG's having a major problem with it also.
no, I think that's actually the motion interpolation which
That's
we're going to get into.
non-defeatable.
Right, exactly. So it's actually passing the 2-3 pull-down detection, but it's making a mess later. It's a different thing.
Okay.
What do we have on the settings? We have everything off.
Absolutely. Film mode's in standard, which is where it should be. Motion enhancement is off.
So basically the elite here is misidentifying film content as video, and it's trying to de-interlace it. It's trying to interpolate this data here from the above and below lines, which is why this 1 pixel high transition is flickering there. And you can see like a real world manifestation of that is it's probably going to be quite subtle. In fact, actually I believe the elite is actually passing here.
It is.
Right, it's passing here, and if it wasn't passing with this real world content, you would see the stands here flickering.
Yeah,
Exactly.
There's a bit of wiring in here, but that's okay.
Do you think you understand why it passed the one? Passes this test and failed the other?
Oh, I mean, I don't know. You'd have to ask
Yeah.
what the algorithms are.
Oh,
I'm assuming that the amount of, because we had like 1 pixel high transitions vertically in the pattern before. In the vertical direction, maybe that was somehow confusing. I don't know.
You want to move on to your your other video
interpolation.
processing?
Okay.
Yeah.
So to demonstrate this, we're going to show actually a custom test pattern that we made for HDTV test. You can throw in HD diag there. So the pattern you're going to see in a minute, the pattern I made here is to basically I made it to check to see what the different motion interpolation options on the TV did. And you guys all know about the soap opera effect, right?
Yes.
It's common use. The reason.
No, what is it? Can you explain it to me?
So basically, a lot of
Days of our
modern
lives.
a lot of modern TVs have image processing built in, which will it'll take frame. Imagine if you're feeding it a 24p film source, or even if it's film material, low motion material, originally shot at 24 frames per second. The TV will look at frame 1 and frame 2, maybe even frame 3. It'll look at a series of frames and it'll generate in between ones. It'll analyze the motion, the way, like the movement of objects in the frame, to generate an interpolated frame. So that's why it basically converts 24 FPS content to 60 frames per second, sometimes 120 frames per second, really high numbers, by generating fake frames which are not in the source. And that's, I guess they call it the soap opera effect because it looks like a soap opera shot in a cheap video camera.
Oh.
It gets very smooth. It gets like,
Right.
It's kind of like
Hyper real of all sorts.
Looks
Yeah,
fake.
it does. In
Yeah.
fact, like we were discussing it last night, like Peter Jackson shooting The Hobbit at native 48 frames per second.
yeah. What was with that?
What's that, sir?
What was with that? Like that story with that?
Well, people didn't like it because because 24 frames per second is a limitation. I guess you can say it's a limitation of film at the time. I think it's the lowest frame that you can get away with actually. Because of the
the eyes will start getting. The eyes will flicker. Well, the eyes will see the
Well,
flicker.
some people perceive flicker, and that's another issue actually, depending on how it's output by the projector and the whatever. Anyway, so this pattern here, interpolation detectors, make sure I get the right one. This is basically, it's designed to catch out displays that are doing weird stuff to the image. Now, all these TVs do have motion interpolation options, so if you like the soap opera look, you can turn it on. You'll see the LG is
Here it's
making
turned on or off?
It's
Turned off. It's turned off.
not
However, it's still on. It's not fully defeatable.
And this is how we tell. And you can see this
Quite
with real
clear on
content
it.
as well. It's going to look hyper smooth. And the reason you're getting this mess on the LG, the way the motion interpolation works is, I believe the ones they're using in TVs, now you need to remember this is a flat video signal, okay? The TV, the video processor in the TV doesn't know that the actor is in the foreground and there's stuff in the background behind him. All it has to work with is pixels. So they have to, I think what most of the systems are doing is dividing the image into a grid and analyzing motion to create motion vectors. And if you have any kind of complicated pattern or complicated motion, things moving in different directions, it's going to fail. It's going to create artifacts like that. So that's that. And all of the TVs here do have controls for motion interpolation. You can turn on the smoothing if you want. The Samsung LED LCDs are actually notable because they let you control the two parameters. You can have the higher output refresh rate, but it's only going to duplicate frames of the source. It's not going to do anything like this and create new in between ones. But you can turn it on if you want. Whereas the plasmas naturally just have very good motion resolution and they don't have to resort to this kind of trick. So we don't know why LG are. The other one is for film grain. And this is a kind of misunderstood topic sometimes because a lot of people aren't aware of the difference between film grain and noise. Film grain is an optical characteristic of film, whereas noise is electronically generated. Modern film scans are done in very, very high-end scanners which tend not to have, as far as I'm aware, maybe some experts can correct me on this, they don't generate any noise of their own. That is, film scanners using CCD imaging sensors have a noise threshold that is below the film grain. You won't see any video noise in a modern film scan. Some older scanning systems, I believe based off CRT technology, would they'd have noise mixed in with the film grain. And I believe there's been a couple of releases of catalog titles from studios. I think Universal does this a lot. Which are, I think, are done off older scans, which were done maybe, a decade or so ago, and they've been quite heavily DNR'd, noise reduced, to get rid of noise.
Terminator 2 comes to mind.
Right. Another really, really bad one was Gangs of New York at first.
Oh boy.
Yeah.
Didn't they re-release it again?
Buena Vista Disney redid it. There have also been some other painful examples.
Gladiator.
Yes, thank you. Yes. Anyway. Yeah, that was redone and looked very good. But anyway, some TVs actually do noise reduction, and we found, here's the film grain test. By the way, there's text going across here. Okay, this was to help another manufacturer fix a similar issue. So this lecture about why film grain should be left alone is, you can ignore that. Okay, it was a message to the manufacturer. So you can see the LG is doing something, and actually this isn't as bad as it looks sometimes, because sometimes it looked like the grain was like kind of scrolling up, like, you know, reverse grain. This is great, full detail, yes, full detail. In Europe, some of the Samsung displays had trouble with this. They would do temporal averaging in the image, which would kind of it would dampen the grain. It would make it look like a kind of crawl, make it look sticky in a way. This Panasonic is fine too, and Panasonic understands this. They've actually, I read a test paper by one of their, a tech paper by one of their engineers, explaining why this was important, why it was important to keep everything intact.
Sure.
So
If the film grain is in there, we want to see it.
Right.
That's
Film grain. Film grain isn't necessarily sacrosanct. I mean, there could be reasons for removing it. Let's say if you have like a big restoration project, which is being scanned off the original camera negative, and there are sections of that that are damaged, and you have to go to an interpositive or even a print, or you know, the lower down generations are going to be grainier, and there are good reasons for maybe degraining in the studio to make it level, to match it out, so it's not distracting when it goes to the replaced footage. But that's done in the studio. That's done in the studio, non-real time, with very expensive, not always very good. But hopefully good, expensive hardware which can analyze the motion in the image and reduce the grain, if they want to, if the director wants it. The next thing I guess would be frequency response, edge enhancement.
Let's do it.
Right. Okay. Could you give me the screws and Munsell? There. No. Okay. So this is chromosome plate. Back one is, come on. Okay, lumazone plate. So you can see right here that Panasonics are doing something to edge enhance the image.
Yeah.
The best one here, I'd say, is the Samsung. This is completely clean. So the pattern, what you actually have here is you have low resolution. These concentric circles looks a bit like a dartboard. This is low resolution here, so this is like quite fat, chunky details, going all the way, like increasing steps, going all the way out to the edge to very high frequency. So these are the finest details you can get, the smallest tiny specks in a 1080p HD image. And the reason we're getting this, right, the four-leaf clover, I don't know. I don't even know. I really don't.
You're getting it in both Panasonic.
Right, but you'll notice that the LCD has less. The LCD has the four-leaf clover. I can only guess that they're analyzing lines of a certain steepness.
And then the circles.
Right, this is moire. This is called moire, and it's happening because, I mean, if you give me the Panasonic remote for a minute, this is the best we could get from this panel. But you'll notice that if you turn, it's fixed, I'll have to go to a different mode, but you'll notice that if you turn sharpness up more and more, it'll obviously get worse and worse quite slowly.
I was told the reason why this was done was for the web browser.
Oh, God. Oh, man.
I'm just passing on what I was told. Reason for it with the web browser is they want the web browser to look sharp. And you know,
to hell with video.
Yeah, right.
Exactly.
Well, the team that designed this particular chip that's doing this is not a part of the display division.
We're talking to.
So when they installed it into the panel, they didn't check it with the display division to see if they broke anything. And I guess they don't have this particular pattern to check it also. So, but yeah, this is caused by the chipset for Viera cache. It's really to enhance the internet as far as the web browser, and also the streaming content, like Netflix and things like that.
Stuff that's going to be lacking.
Right.
Fortunately, you don't see it in Blu-ray.
Right. You don't see it in Blu-ray from your seating environment. Now, if you're up here like this with a paused image, yeah, you can start, and you have another reference beside it, like say for instance the Samsung. Yes, you can start to pick out small, minute things, but you will never see it from where you sit.
When we mention edge enhancement, people are going to think of like really badly mastered DVDs or Blu-ray discs that have big glows around people's heads. It's nothing like at that level. Okay, it doesn't affect. Right, it doesn't add visible halos in the image as much. It's only for the high frequencies. So You can think of this basically. You can think of you can basically think of this as like a contrast enhancement at the single pixel level. It's just going to make things a little bit edgier if you have your nose up against the screen. Which begs the question why they did it in the first place, right? Okay.
He's saying because they said
Marketing. Firmware.
Marketing.
Marketing. Exactly. It's called
They don't want to fix it. They just design and clean up dirty video on the net. Right. So, but in fact, you got to give them an hand. If it does a decent job of that, it doesn't do bad things to high quality video, then it's not a bad thing.
Right. And I only show them this.
We don't find any. There's no edge enhancement in the test material that we look at. We can't see it in content. My first question was, well, then what'd you do it for? But if you did it for that purpose, it does sound that way to me. Yeah, exactly.
Someone made a very good point here. The Elite has some wiring out here, which I don't think is being caused by image processing. That could actually be related to the subpixel structure in the panel. It's not a big deal either way, but neither is this even. The thing you need to remember is that it only takes a little bit of tinkering to make this look like a complete mess. Whereas you've seen it with actual content and it looks fine. So
If you considered that maybe the width of these pixels vary, the subpixel varies.
Right.
The blue is going to be wider than the
Exactly.
green and red, and that may also contribute to.
right, exactly. Yes.
Yeah, well, on this one, we do know that the green subpixel is larger than the red and blue.
Variable
Oh,
width
it is.
phosphorus.
Yes,
Oh, I see.
Yeah.
They tailored the aperture.
Yeah, and the reason why they changed it is to increase the light output, basically, and for it to be more efficient
Energy
at the same time. Yeah.
In the good old days, we increased the blue because it was the weakest one.
Right.
Yeah, right. Okay.
Yeah.
You're trying to get more light out of that blue sucker, right? The same thing was true of the CRTs, of course. The blue was the light output width
You could show Mission Impossible 4 on this.
Yes.
But we would need to invite people up. We identified a shot a couple of nights ago where it's Tom Cruise looking over the city, and on the panel that isn't tampering with the image, there's like railroad tracks or something in the distance, or windows in a house, and they were there. But in the Panasonic, they look slightly darker and slightly edgier, so it's just very, very minute detail.
But you couldn't see that from back here. You had to get your nose 3 inches off the screen.
How come there's no circles on this one? You'd have to ask Panasonic. I guess they've
the same size.
I guess they've deemed the what they think is the better processing for the high-end plasma, but not the LCD. The ST50 plasma, at least in Europe, I assume the US as well, the ST50 plasma looks just like that. So
we still back at wide 40 Pro.
what's that, sir?
So we still back at wide 40 Pro.
Right, and we said last night maybe it'll be a love heart next year.
Maybe next year.
Right, exactly. Lucky the Irish.
Question, the Panasonic and the Moray issue is targeted toward the web browser internet. I assume that it's non-switchable. So when you're not,
we've tried to defeat this. We spent hours looking through the menus.
so when you're off the internet and you're looking at a
You're off the internet looking at it right now on a Blu-ray test
Yeah.
disc. So yeah, it's there.
But
you don't see it.
the group that created that chipset that's doing this was talking to the display group. What they could have done was shut it off for everything except the streaming stuff.
So it is a mistake. It's not an intended feature for the
Yes. Okay. Yes. It's not. Yeah.
It isn't a big deal.
It's
It's not a big deal. Okay, just one last thing to mention, just so we can prove we went through everything. This is not a big deal. The US models have a content type setting, which actually makes more edge enhancement on the graphics mode. That is the lowest amount of enhancement we can get out of it. But again, we should put some more content on now and show it's.
Let's do it.
Compare the sharpness in both. It's not a big
MI6.
deal.
Yes.
Yeah, that's
Just one question from the audience.
FTP up.
One question from the audience here. They said, did we increase the sharpness? You saw me increase the sharpness earlier. I put it back. This is the ISF 9 mode. Sharpness is at low 0. So FPD, that's right.
FPD?
Yes, please.
I'd have something to work on.
Gotta give you something to do,
And this is in Source Direct. So test first or real world first? Let's do the test. Right, so motion resolution test. In a minute, this is going to start moving. You have low frequency at the top. This is again chunky details, very fine details. And what you'll see is that I think all the displays now do quite well for this, especially the LED LCDs that do backlight scanning and motion interpolation and stuff like that. What you're looking for is you can see there's 4 lines here, and you want to look down when it begins to move. It's all, of course, full resolution and static, but you want to look down and see what is the lowest point at which you can still determine that it's 4 lines. You'll see this is kind of doubling and flickering up, whereas the plasmas are keeping the whole image sharp.
Of course, if you put the frame interpolation in, you'll get a higher number.
And that's another point here. This Panasonic in the corner is managing about 300 lines. This actually does have motion interpolation features we can show you, and I'm going to explain why we didn't use them in a minute once it begins moving again. It's a motion resolution test pattern. I don't get why it stays static for the first 20 seconds of it. Right. The US models, it's called motion picture setting. In Europe, it's called intelligent frame creation.
I don't know why they
You
go to
laugh,
trouble
not me.
to rename stuff. Yeah.
There. Right. So if you turn this on to low and it begins interpolating frames, you'll see immediately the motion resolution gets much sharper. And the reason we have it off is because we calibrated for film content, and with the interpolation test pattern, the HDTV test one, we can see that even the weak setting is applying a little bit of motion interpolation. The Samsung LCDs don't, they have this configurable, so I want to go ahead and bring the plasma here. This is configurable in the Samsung LCDs. They deserve credit for doing that. So in the Samsung displays, you have, in the UK it's called Motion Plus, here it's called Auto Motion Plus for this one. You have blur reduction and judder reduction independently adjustable. Blur reduction, if we dial that up, that's going to make, hopefully it's going to improve the resolution a little bit here. Yeah, a little bit. It's better than some of the smaller size panels. If you have judder reduction up, then that is what causes the soap opera effect. So you can, on the Samsung LED LCDs, you can adjust it independently. You can have the higher motion resolution for video content, but without the soap opera look coming into films. Panasonic doesn't have that level of adjustability.
Sharper when it's standing still.
Of course, yeah.
No, I'm saying, say it on the VT50.
What's that, sir?
This looks a little sharper than the VT50 when it's standing still.
Really? Let's see.
Good thing video is motion.
Right, who watches still pictures? You say this looks sharp to you?
No, actually, it's not as sharp.
I don't see it.
No.
This is what you really want to see right
Yeah,
here. You see how this individually broken out
You gotta
lines?
get close almost
They
to
go
see
all
it.
the way to
They're the same. Every display in the market now can.
I
Every.
think yours is, I think that's a little darker up there. And from here, my eyes are getting the.
Oh, okay. No, but every display in the market now can handle static resolution if it has a 1920 by 1080 panel. Some of them, if you have the sharpness control and some of the TVs set to, you have to find the best setting for sharpness, because with some TVs, putting into the negative figures or 0 actually blurs it. And you can set that with a pattern like that, or ideally with the zone plate we showed you, or the global plate we showed you before. Okay, so real world examples of this. The FPD benchmark disc has these clips we use a lot, like the, I don't know if you've seen this disc before, it's a Japanese disc that we, I think a lot of reviewers use for assessing motion performance. And I think it was actually made by the PDP Development Center to show off the superior motion resolution of plasma, but the LED LCDs are doing a quite good job now as well, so. And we will do swing.
That monoscope is real good for panel response time. Smearing.
No.
Yeah.
Particularly.
Oh, there you go.
So these are all doing a fairly good job at this, I'd say.
Look at the hair.
I guess what we're looking at. This is like, this shirt is like a test pattern itself, right? Yeah, okay. So with motion interpolation, like we saw in the checkered box pattern that we made, again, remember it's dealing with a flattened video signal. The TV does not the TV doesn't know this is the background, this is the foreground. It's just pixels to it. So often with some motion interpolation systems, around the edges, you'll see of the girl moving, you'll see this kind of shredding. Maybe like when she moves, she'll take part of the tree with her if the motion interpolation is turned on. And I don't think there's a little bit of it here because it's a high frequency foreground and high frequency background.
Around her fingers,
right?
For the trees.
But I mean, for remember that the TV has to process this on the fly in real time, and that's quite impressive for what it's doing. Of course, the plasma has naturally high motion resolution, so you don't need any of that processing on it. This is actually quite a good demo because this is actually the interpolation features in this are shut off, aren't right? Because they add the soap opera effect. So for I guess for fairness, we should.
I didn't see any soap opera effects on mine. Maybe I'm just not.
What do you have? Do you have the?
I had it on 120 low.
Oh, you do?
Yeah.
120 low is a very gentle interpolation.
It's very good.
That's the right setting, by the way.
Yeah.
So this is a good example of motion artifacting in both technologies. This is what we always say: the LCD, if it's unassisted, the LCD will get blurry, whereas the plasma will get noisy.
This is off, by the way.
Yes, this is motion interpolation off on both panels. The plasma will get the LCD will get blurry during stressful motion, whereas the PDP will get rougher, noisier, coarser gradation. We can ask our expert here if that's part of the technology or if it's in the design.
You're getting like some chromatic.
So see, if you see some chromatic, you're getting kind of fuzz.
Oh yeah.
You see around your thumb,
Yeah, you're right.
See around your thumb, you get like a chromatic.
Right.
Aberration
This is phosphor after
Right. Right.
It's the when the phosphor is bless you. when the phosphor
it's a phosphor thing. The phosphor thing.
When the phosphor is ignited, it doesn't when you light it up then ask for it to not light up. It doesn't. It's not instantaneous. It's like turning on and off the light bulb.
Well,
It fades.
some people see that easier than others.
Right.
Not
Some
everybody
people
sees it the same.
You know, a really good test for actually is Sin City or any kind of black and white high contrast film, and you probably see that if you dart your eyes around the screen, you'll see streaks of like yellow
I
and
think
green.
most people don't see that.
Most don't.
The baseball goes across the field at night, and you see one side of it's green and the other side's
Right.
That's it.
Right.
Yeah.
Everybody's eyeball is different.
That's right. Phosphor is different.
Everyone's
Off the
motion.
lag,
Is that
everybody
the shadow behind
You don't see it on here?
I never see
I
phosphor.
don't have a photographer. I'm very on chromatic aberration. I mean,
A shadow behind her arm. Okay, so this is another point here.
Chromatic aberration is with lenses.
no, that's a lens. Yeah, it's a lens thing, but it's a similar effect where you get the red and the green.
You're not looking at it for different reasons.
So someone else pointed
Cheap
out
lenses
here.
have.
Yeah,
Someone
that's
else
right.
pointed out here that they can see they described it as a shadow swinging behind her on the rope.
Yeah,
it's going to be hard
it's like
to
a ghost.
see.
It's like a little
It's
ghost.
going to be hard to see. Whoops, from your.
Especially now.
Yeah.
It's going to be hard to see from where you're sat, but Panasonic was actually quite bad for this last year. We called them in reviews. We called it fuzzy double images, and we've got a better test for this actually. If we pull the menu back up a sec.
It's like a ghost.
Yeah, it's a ghost.
Right. No, the Panasonic completely revamped the
soul's trying to get out.
Where are we? This one. This was good for showing it, and I think this is another clip because static for the first 10 seconds or so. You'll see when it starts to move. I don't think any of them do badly in this at all, actually. But when it begins to move, last year Panasonic actually were. That's all very good actually. Last year Panasonic were pretty bad for this in the plasmas. You would have what we call fuzzy double images. You'd have a kind of noisy shape following the characters as they move, whereas when they revamped it with the 2500 Hz focused field drive, it's gone now. You do have a little bit of noise coating the entire image, but importantly, it's a uniform dither. It's across the whole thing, so you can't pick out any. The noise doesn't form distinct sort of shapes anymore. So all the players have been pretty damn well for that. And you'll notice you'll sometimes get purple trails in the LCDs. The Elite's doing very well with that. Not having it, I mean. I think IPS as well. IPS LCD naturally has very good response time, so it's usually an issue with EA type panels. I think that's that.
All right.
Yes.
Thank you, David. Thank you very much.
Thank you.